Example 12.1c, let's look at finding the vertex form once again for the given equation. We have f of x equals 5x squared plus 30x. So this is, again, standard form. And from this standard form, we can identify that a is 5, b is 30, and c is equal to 4. So once again, we have an issue here where the leading coefficient, which is the a value, is not 1. But in this case, it's 5. So we're going to be mimicking a lot of what we did in example 12.1b, except here we have a c value that is 4 and not 0. So we can actually see the value of the constant there, that plus 4. So this is going to go against a lot of what you've been taught over the years for factoring in terms of always factoring out things from every single term. We are just going to focus on taking out the 5 as a common factor from the first two terms. I'll show you how all this is going to shake out here in just a bit. So let's start with taking out just the 5 as the common factor, or as a common factor, from the first two terms. So if I factor out just a 5, then I will have x squared plus 6x. So what I have written that I'm underlining in red is equivalent to what I have in parentheses in red on the line above. So all I have to do is bring down the plus 4, and now these two statements are 100% equivalent to each other. It's just rewritten in a semi-factored form. Now we're borrowing the idea of factoring to meet our specific needs. So I want to now apply the creative zero aspect to this. So we're going to add our creative zero inside the parentheses with the x squared plus 6x. So to do that, I'm going to go ahead and copy down the x squared plus 6x, and then I'm going to leave a little blank space here and come over here to the side, and I'm going to do my creative zero calculation. So for my creative zero, I'm going to take 6, divide it by 2, and then square it to give me 3 squared for a grand total of positive 9. So we are going to add 9 and subtract 9, close the parenthesis, and then I'm going to add 4 there at the end. So once I'm done with the creative zero, I'm going to then group the first 3 terms like we've been doing inside the parenthesis, and that's what's going to form a perfect square trinomial. That will be factored as x plus 3 squared. There is still a subtraction of 9 inside this parenthesis, and then outside the parenthesis I have plus 4. So I kind of have a little bit of this vertex form showing. If you look inside your parenthesis here, that looks like vertex form. But I want the whole equation to have that feel to it. So in order to get that, I need to do some distribution. I'm going to take the 5 that I factored out at the beginning, and I'm going to distribute that with the 2 terms that are inside my parenthesis. So this is going to give me 5 times x plus 3 squared minus 45, and then I still have the plus 4 there at the end. So the only thing left to do now is to combine the constants at the end together. So we have 5 times x plus 3 squared minus 41, and that gives us the vertex form for our equation. And we can identify that a is still equal to 5, h would be equal to -3, and k would be equal to -41, which means that our vertex is located at the ordered pair -3, -41, completing example 12.1c.